Good morning, everybody. This is MTH 242 slash CSC 414 again, the second video, as I promised. So this morning we are looking at our second iteration method, which is the regular Faulsi method. The regular Faulsi method. Um, Another way of referring to it is the method of false um, false position. So that's the other way of describing it. And I told you that it was designed around like some 3,000 years ago, if not more, by the Egyptians. So that shows you how important it is, and the relevance of it still stands, even though there are other modifications. In fact, what we are teaching today is in fact a modification of it. This isn't what the Egyptians did. No, but over time it has been tweaked and tweaked until something this cool comes out of it. Okay, so what we are going to use it for, as usual, is to find the root of an equation. To estimate the points where your curve crosses the x-axis is actually quite a beautiful proof, a technique. So let me sketch it. Let me sketch it so that we can see. So we have our coordinate system out like that. This is the y-axis and this is the x-axis. This is the origin 0, and then we have a curve which behaves that way. All right, so the curve, we call the curve our f of x. Okay, so we know, so somehow we know that this curve has two roots as it is. We know that there is a root. Let me pick a red color or something. Okay, there is a red root. There is this point which is a root, and that point is another root. So we want to estimate at least one of them. We will even be lucky, since we can't even normally find any of them. We will be lucky. I mean, using the traditional methods, we will be lucky to even find one. So the technique says that we should draw a straight line. Well, that line sucks. Let me reverse it. Okay. So so we should draw a line. Okay, let me just tilt it. Okay, that's not bad. That's not bad. So we have that line. Okay. So we look at the points where the line crosses the f of x at this place. We trace it down and we can mark that place as our x naught. Okay, we mark that place as our x naught. Then we come to this place. This is where it crosses it beneath the. Then we come here and mark this place as our x1. Now the straight line crosses the x-axis at this point. So it means the straight line itself has its own root at this place. So we can call this place um, x bar or x2. Let's call it x2. All right. Okay. So let's talk about coordinates. So since this is a f of x, as in this curve is a f of x. I mean this curve, that's a f of x. Then it means this point, if we trace it to this side, that would have been f at x naught. Okay, and this other side here that I'll just put a little arrow at, if we trace it to this side as well, this place would also give us f at x1. Okay, now let's talk about the okay, so I think that's about all we need for this diagram, but let's talk about the conditions for using um, a regular Faulsi method. Conditions. One, of course, f of x must be continuous. F of x must be continuous. That is, the curve must have no breakages. No, okay, no breaks, or yeah, let's see, it must not break, must have no breaks. All right. So let's say that. Then the second condition, which is actually the most important condition, is that this is a x1 here. This point we've called this one, okay, f naught. I will call this point here x1. Maybe I should pick another color. Okay. So both of them must have opposite sides. That this is x1 and this is x naught. The f value of them, that is f x naught and f x1, must have opposite signs. That is very, very important, and I would explain the reason why that is so. Okay, the reason why it is so is that we this line this line comes down like that, and it crosses the x-axis at this point. All right, so the upper part of it is positive, the lower part of it will be negative if it has to cross the x-axis. All right, so it's just like this. Okay, we want to cross the x-axis. It means the upper part here must be positive and the lower part here must be negative for us to know that the line has crossed the x-axis. If not so, well, we will not be able to use this scheme. So those are the two conditions. I may ask in the exam that you should state the two conditions for regular Faulsi to work. Okay, so please note that. The exam is not all about you coming around and cramming nonsense and, theories. We want to be sure that you understand it. So I'm saving the page before we go on to the proof. Okay, so page saved, border being determined. Now let's go to the proof. So those of you who are in chemistry, and all of you actually must have passed through me, except if we have folks in chemistry who joined us in the second semester, I mean, the second year, and folks in 400 level who actually joined us in 200 level. Those are the only ones that I can exempt from what I'm about to talk about. In your 100 level, I taught you 112, which is coordinate geometry, and we can see it's coming to play here. We're, toying with x and coordinates x, comma y, and all that, all whatnot. Okay, so from okay, I think I may have to. Okay, let me just check. Let me sketch what we had earlier. I might have, please, if this sketch is different from the one we did before, this one supersedes the one we did before. So I think I need to just go back to it again because I don't think I'm not sure now that I properly established the coordinates. I call this place x naught. That's I established. Okay, and when it comes to this place, this one will become fx naught. Then I call this place x1 so that when this place will come fx1. Okay, now I call this place where this line crosses the x-axis, I call it x2. I think we all remember that. So the coordinate of this place now will be x1 comma fx1. I'm sure I didn't mention that in my last diagram. And this place has the coordinate x naught comma fx naught. All right. And this very center, the coordinate of this place will be x2 comma 0. I wish I was in the physical class where I would have awarded a mark for that. Okay, so now let me partition my board into two. Okay, and we can now start talking. So like I was saying, this straight line has passed through 2 points. Actually, it has passed through 3 points, but let's consider it's passing through 2 points. In 100 level coordinate geometry, I specifically said that we are going to need this thing. That is the equation of a line passing through 2 points. So here we now have to generate an equation for this line that is passing through 2 points with the intention of determining the value of the x2 here. All right. So equation of a line passing through 2 points. Let me just obtain it using a different method. I mean, the method we used back then, so that it's just to refresh your memories. So we know that from the equation of a line, uh, we can find him. That is the first one. Um, if we call this point A, point B, and point C. So between point A and point B, we know that m is going to be, I mean, that's the gradient now, is going to be changing y, that is f x naught minus fx1 over x naught minus x1. That's what that is going to be. Okay, don't ask me why it is so. That's the same thing as the y, changing y over changing x. Now let's now consider point A and point C. All right, the line still passes through it, so hem in that case is still going to be the same hem because it's a straight line. A straight line has the same gradient all through, so it's still going to be hem equals this time f naught is 0, as in the f2 is 0 now, now minus f x, mm, I think that's fx naught over x bar now, or x2, sorry, x2 minus x naught. So that is the second uh, formula for the gradient. So since m here and m here are the same, so we can actually equate the two. We can equate the two now and say that fx naught minus fx1 over x naught minus x1 equals minus fx naught over x2 minus x1. Okay, so we can have that. Now, don't forget what we are trying to estimate the value of x2. We are trying to estimate the value of x2. So this is what we are trying to estimate its value, x2. Okay, that's what so we now make it the subject of the formula. We make x2 now the subject of a formula. So we are going to be having something in this region. Let's cross multiply. So we are going to have minus fx naught multiplying x naught minus x1. Okay. All right. I think I can squeeze it on the other side. Equals um, equals x2 minus x1 times fx naught minus f. Oof, this is messy. Okay, let me redo it. So we have something like minus fx naught times x naught minus x1 equals fx naught minus fx1 times uh, times x2 minus x1. Okay, so from here we know therefore that x2, don't forget that's what we are looking for, minus x1 is in fact minus fx naught times f times x naught times x naught. Excuse me, let me erase that. So times x naught minus, that's minus x1. I'm trying to go as slowly as possible so that you'll be able to follow. X1, all right. Of course, we have to divide by this guy over everything over fx naught minus fx1. Fx naught minus fx1. Okay, so we have arrived at a very convenient junction now. So I think I can now save this page. I can save this page. I'm going to send all the saved pages to you. And having done that, therefore, we can now finally finally establish our law as x2 equals x1 minus fx naught into x naught minus x1 over fx naught minus fx1. All right, so we'll continue with the iteration using this method. This is the regular. So this is now officially the regular Faulsi method. Okay, so I'm putting it in a big box. That's the regular Faulsi. That's the RF scheme. So you have x2, x3, x4, and x5. So how that will happen, I would explain later. So, okay, let me just explain it now. So when you have found x fx1, when we have found x2, all right, you test it. You test it. Okay, test x2 or fx2. Test fx2, which is the new value you have obtained now. Aha. If fx2 is okay, has the same, if it has the same sign, that is okay, sign as either fx1, fx naught, or fx1, then replace fx naught or fx1 with fx2. Okay, so what I'm saying there may sound funny, but then well, don't get mad at me. I'm going to explain what it means. What it's saying in essence is actually quite straightforward. What I'm saying is that, so you know, one of our instruction back then was that fx naught um, and fx1 must have opposite signs. That is, if fx naught is positive, then fx1 must be negative. Okay, so now if what I'm saying at this place now is that if you have obtained x2 and you test fx2 and it is positive, positive, okay, then you must replace it with fx naught. You must replace fx naught with it. So it means that it is a better approximation than fx naught. So you are now going to pair fx2 with so pair fx2 with fx1. All right. Also, if the reverse is the case and fx2 is negative, then pair fx2, which is the new thing you, I mean, sorry, you pair x2 with which is negative, then you pair it with x naught, which is a positive in the new scheme. So that is how you are going to continue to be doing it until you reach a form of closure. I hope you understand that weird sounding scheme. So I'm going to save the page again, and um, I'm going to give you everything later. Okay, so now we move to an example. Okay, example. So we are looking at a function f of x, which equals x cubed minus x minus 1. So they are asking us to find the root of this equation, or I mean, sorry, of this expression, which is going to be quite difficult to do if you want to use any of the available methods. Actually, I don't know the method you can use to solve this problem, because if we want to use is it binomial theory? I mean, there are all those methods that we learned in other level. it may not work because I can't think of anything we can put into this place to give us 0 first. So because of that, we can't start talking about it. So let us draw a short table. So now we want to know what our x naught and our x1 will be. Okay, we will need to establish that one. So what you do is that you draw a small table. All right, this is totally like a guesswork thing. All right, so you draw that small table. This is 0, this is 1, this is 2. So what is, if you put 0 into this expression, it's going to give us -1. If you put 1 into the expression, it's give us -1 as well. Okay, but if you put 2 there, it's going to give us 5. Okay, it's going to give us 5. That is 2 cubed minus 2 minus 1. That's going to be 8 minus 3 minus 2 minus 1, which is 5. All right, now we can see now that f at 1 is negative and f at 2 is positive. Okay, f at 0 also is negative. So we can therefore pair uh, 0 and 2. Okay, we can pair 1 and 2, but we can't have there's no way we can have 0 and 1 because both of them have the same values. So, and the instruction says that we must never pair those two that have the same value. So we won't be needing that. Now, even of these two that we have here, between 0 and 2 and 1 and 2 are, well, 1 is closer to 2. So why should I start from the back? If I start from 0, it means that my iteration will take a long time. So why don't I start from 1 and 2? Now, what this is saying, in essence, let me quickly draw a short graph, is that what is saying in essence is that this is 0, and this is 1, and this is 2, okay? F0 is F0 is -1, F1 is -1. Okay, so it means actually, and F2 is, oh, sorry, this is plus -1. So F0 is -1, F2 is -1 as well, and F at 2, it is +5. Okay, so this is +5 here. It means somehow the curve would have wobble and come like that. Okay, in a way, come like that, then go up. Hope you understand what I'm saying. So it crosses the x-axis at this place. Okay, so if you say you want to start from this place, then it means that if you are starting from 0, it means that you may have to get to 1 first. So why don't you just start from 1 and start seeing how you can iterate your way to it? Okay, when I'm done with the whole thing, I would explain finally the what is happening in this technique. Okay, but let us get the technique first, then we would explain what the technique is doing. All right, so that everything will become clearer. So we are going to pair our, what we are going to pair now will be 1, x1. We will pick x naught to be 1. We'll pick x1 to be 2, and we are looking for x2 now. So that's what we are looking for. So I'm thinking that I should okay, no problem. Let me just write out the formula here. So the formula we have before, so x2 is the same thing as x naught minus f naught, fx naught Sorry, excuse me. I'm kind of messy this morning. I don't know. Okay, f x naught, all right, times x naught minus x1, everything over f naught minus f1, fx naught minus fx1. So that's the formula that we are going to use. That's the formula. Let me scribble it quickly somewhere. X2 minus x naught minus fx naught x naught minus x1, excuse me, and fx naught minus fx1. Okay, so I think this one is not looking good. So this is x naught. Okay, so I think we're good now. So let me clear my board. Let me clear my board. Let me save the pages. Okay. So now that we have that, let's start. So x2 will be okay. X2 will be x naught, which is 1. Okay, let me, x2 equals x naught minus f x naught times x naught minus x1 over fx naught minus fx1. All right, so let's put these guys in that square bracket. Okay, so that we have that, so we can now proceed. We know that our x naught equals 1, x1 equals 2, f x naught equals minus 1, and fx1 equals 5. So if we put all that together, it means that our x2 is going to give us 1 minus, open the giant bracket, what's my fx naught, minus 1 into x naught, which is 1, minus x1, which is 2, over what's my fx naught, which is minus 1 minus 5. Then you close this giant bracket. If you resolve this thing, it's going to give you 1.6667. Okay, it's going to give you 1.6667. When you have that, just wait for it. When you have that, we test it again. So we now test. So what's going to be f at that point? 1.6667 is going to give us minus 0.5787. Now it's negative, which is a negative. What's the implication of this? It means that we'll replace from the initial ones, x naught and x1. We know that x naught, which is 1, gives a value at f of minus 1. So it means we will replace that whole episode. So replace x naught with x2, and of course fx naught with fx2. So we pair. So our pairing now will be between x2 and x1. So we run this scheme again. when we run this scheme again, we are going to have x3. It's going to develop x3. So x3 is going to be we running it again. So wherever we see x naught before, we now put x2. So you are going to have x2 minus x2 minus um, fx2 fx2 into x2 minus x1 over fx2 minus fx1. So you close it like that. And this one, when you do the math, let me do. I don't have it here, but let me just write out what is you are going to get. So I don't want you to struggle for anything. I want you to understand this thing right from the box. So that's going to be okay. Let me clear that one. Excuse me. Excuse me. Excuse me. Excuse me. I hope you are following this scheme. It's really a lovely scheme. So this is going to be so x3 now will be what is my new x2 minus 0.5787 minus, then you open the big bracket. What's fx2? Oh, shoot. Sorry. Okay. Sorry. I'm clearing that again. Sorry. I'm using fx2 in the place of x2. So I'm sorry about that. So, so now we are looking for x3, and it's going to be x2, which is 1.1667, all right, which you have written out, minus, excuse me, I don't want it to confuse you in any way, okay, minus, good, open the giant bracket, the f of this x2 now will be minus 0.5787, okay, times x2 minus x1. How do I squeeze this thing in? My goodness. Okay. All right. This is what I'm going to do. I'm going to clear the entire page. And I won't divide my screen into two again. I'll just use it straight up like that. So let me save the entire page. Excuse me. Let me save the entire page and create a new. So rather than me dividing the screen into two, I'll just use it straight up like that. So we know now that our x3 is going to be x2 minus the giant bracket um, fx2 times x2 minus x1, everything over fx2 minus fx1. All right, so this is going to be our x2. When we did it, we got 1.1667, and now minus our fx2 is minus 0.5787. All right, we will use it to multiply x2, which is 1.1667 minus our x1. Don't forget, what's our x1? I wish I was in a class. That's a mark going for someone. So that would be 2. X naught was 1, x1 was 2. All right. So we'll close this one up again. Then divide everything by fx2, which is a minus 0.5787 minus fx1. My fx1 is going to be 5. Yep, fx1 was 5, so it's going to still remain 5. So 5.000. If we resolve this dude, it's going to give us um, x3, which will be um, x3 will be now 1.2. You can test it, 1.25311. If it is not so, go back to what I did. It means I've made a mistake. I got this straight from the textbook. I made a mistake in the workings, and then please you can help me to correct it. So wherever you test fx3 to know which one to replace, definitely it's going to give us something like a minus 0.28 3 6, which is negative, so it's negative. It means that x2, therefore, since fx3 is neg, then x3 replaces x2 in the next scheme of finding x4. So when we try to find x4 now, so x4 now will be x3 minus fx3 into x3 minus x1 over fx3 minus fx1. So you close that again, then you run it. It's going to give you, definitely it's going to give you a minus 0.127. Sorry, it's going to give you, sorry, that's a that's a function 1.28344, and fx4 is going to give us something like minus 0.1954, which is also negative. So you still replace x4 with x3. If you yeah, if it was positive, it means you would have replaced it with x1, but that is still negative. So it's like you are approaching it from a particular side, from the side of negative. So in the end, because I'm going to give you an assignment based on this, I'm going to clean. Okay, just for me not to waste my screen, you replace x3 with x4, and you're going to have x5 will give you something like a x4 minus, open the bracket, fx4 into x4 minus x1, close the giant brackets, divide everything by fx4 minus fx1. Bingo. So this one is going to give you, so x5, if you do all the replacements you need, fx5 is going to give you 1.31128. Now assignments your assignment. I'm going to write out what the other values are till we get to so I'm going to, this time around, I can, no, I don't even need to. I can just write straight up. So I can tell you for free that my x6 is going to be 1.3189899. 899. My x4, I mean x7 will be 1.32228. My x8 will be 1.32368. My x9 is going to be 1.32428. My x10 will be 1.32453. My x11 will be 1.32464. Okay, so what you are going to do now, these are the values after iteration. I want you to show in this assignment, so this is going to be your assignment. Okay, find fx6, fx7, fx8, fx9, fx10, and fx11. Okay, and when you okay now, okay, don't find fx11. Let me tell you fx11. Okay, fx11 is going to give you 0.00034. Okay, which if you look at it is quite close to zero from where we are coming from. The first one we got was I think 1.66 something, and when we did the f, it gave us something. Let me see. F, and I'm talking about x2 now. X2 gave us 0.5 something. Yep, minus 0.5 something, but this one is giving us, it's a minus, I'm sorry. It's a minus. Okay. Okay. So when you look at it, you can see that you. So I want you to do this assignment and see how this thing progresses, how it converges towards zero from the 0.55. From we got 0.55. I mean 0. X naught was fx3. fx2 was minus 0.57. fx3 fx3 was minus 0.28 something. Fx4 was minus 0.1295 something. I want you to see the progression as the whole thing collapses to minus 0.00034. I want you to see how it goes. So that is the theory behind the regular Faulsi method. Now, the next thing I'm going to show you is what did we just do? What did we just do? So I want to show you what we just did. It's actually quite exciting what we just did. Um, this is what we did. We have our coordinate system like this, and we have a curve that goes like that. All right. So we wanted to pick this place and estimate it. All right. So we drew a straight line to cross it. So we pick a point here. We call it point x naught, which we trace up here. And we call this one fx naught. Then we pick another point here and we call it x1. When we trace it down, it gives you fx1. Now we look at this point x2. Okay, we look at point x2. So let me pick another color because that was what we have done. So I'm picking another color because I want to use it to demonstrate. Let me pick a brighter color, something like reddish. Okay, great. So what we did is this. So we are either coming, we want to estimate either this or this point. But let's assume that it is this point that we are trying to estimate. Let's assume that we are trying to estimate the point here. Now, this is the first value we got. When we got x2, we got something. All right. Now, x2 is negative. Sorry, okay. When we got this guy, okay, sorry. We use this guy to estimate the next item, which is a x3. All right. So it means that we would now change the line. Okay, we change the line away from x2 because we know that. So we take the line away from x2 and come here. So we know that when we draw it down like that, x2 now becomes a negative number, now has a negative value. I hope you understand that. And uh, okay, let's call this one x1. Don't worry about that. Don't worry. Uh, yes, let's call this one x1 since x1 is positive, and let's call this one x naught since x naught is negative. So we will no longer need this x naught again. Rather, we need x2. So x2 now is a negative number. So we can now draw another line like this. Okay, so this one comes here like this. So we now have this place to be x3. Okay, if you test x3 against the it's still negative. All right, so it means that it's now better. X3 is closer to x to this point that we are trying to find. Let's call that one the ultimate. Let's call it the root point. Okay, so x1 is standing back here, x2 is close to the root point, but now x3 is closer to the root point. All right, so we discard x2. Now we run it again and we got x4. Okay, we got x4, which will be another line. Let me pick another color to represent x4. I'm running out of color, but then yeah. Okay, so I picked another color to represent x4. Okay, so that one comes like this. You can see it's closer. Its own root will be closer to x1. So in essence, what we are doing is that we are shifting lines. Uh, we are shifting lines. So we are coming to this place. All right. So we started with a line that was here, then a line that was here, then another line, you know. So you can see, but we know that we can find the value of this place, we can find the value of this place, we can find the value of this place, we can find the value of this place. So if we started from here at x2, and then we got to x11, you know, we got to x11, which was pretty much very close to the root. This is the root, which we know we can never find. We can never get to the root, but we can get close enough to it. And we had to go 11 steps to get close enough to the root. So my second assignment for you is, okay, let me write out the assignment so that you won't say that you didn't see it, because you guys can be very funny. So my assignment will be, okay, my assignment one. Okay, convert this video into a note. Okay, I'm going to check this note. Don't think I'm joking. I'm going to check this notes I'm asking you to convert. And if Posse Boys notes is the same thing as Posse Girls notes, I will cancel both notes. I want something different. I want you to understand this thing and write out what you understand. That's what I want. Okay, so convert the note first. Number two. Um, number 2, number 2, number 2. I want us to actually get a better root than we got for in that our assignment. So for f of x equals x cubed minus x minus 1 again, I think we can start our root estimation from, I want us to start our root estimation from x naught equals 1.32, and x2 equals, instead of us picking 2, maybe we can pick something better. Maybe you can pick something better. Let me see what 1.5 will be. If it's negative, let me just give me a second. Let me. Okay, you can even see my screen, so it's okay. Let's check together. Okay, where's my calculator? Let's check 1.5. Let's check 1.5. Cancel. So 1.5 cube raised to power 3. Okay, minus raised to power 3. Okay, minus 1.5. Okay, this is looking good. Oh, this is good. Minus 1 is positive. So that's so let's use okay. Let me try my luck again. Let me say 4. Let me see 4. This way we are going to get better. I think I'm positive that we're going to get better estimates this time around. Let me cancel out that and replace it with 4. Oh, we're still positive, so 0.3. So we can use 1.4. Okay, let me let me see if I can still be lucky. 1.3 hits. 1.3 hits. Well. That looks good. So let's use 1.38. I know 1.32. Let me be sure so that we're not doing rubbish. Let me be sure. 1.32. Okay, 32. Okay, excuse me. Yeah, this one is negative. Fantastic. So, okay, that's good. So, I'm coming back. So, I've ruined, I've ruined everything I've been writing. Sorry about that. So, I'm going to start the assignment all over again. I don't know what happened to the software. Sorry. Okay. So, assignment. Okay. 1. Convert the note, the video, into excuse me. Sorry. I'll call her back. That's Miss Victoria. Convert the video into a note. That's number 1. Number 2, find the root for fx equals x cubed minus x minus 1. with x not being I think 1.32 and the x1 being 1.3. I think 1.38 should work. Okay. 1.32, yeah. So these two will work. Thank you very much. Um, so I'll sign out now. So that's Dr. Adifukun. CSC. And the video was made, today is 17, I think, 17/03/2023. Okay, stay safe.